Hi, in an earlier video I showed you how to clean the plungers and the circuit board on one of these. This is a NuTone mechanical 4 or 8 note long tube chime base, and that video has actually turned out to be very popular. It has a good number of views, and I've had a lot of people contact me and tell me they were able to follow along and do what I did in the video, or they see the video and they send me their bases and I clean them for them. And this particular base came from a customer who did what I said in the video and disassembled her chime and cleaned the circuit board traces and cleaned the plungers like I said. And she did that after she took the chime down because she was moving from one house to another house and she wanted to take her chime with her, which is not an uncommon thing for people to do. People get attached to their door chimes and want to keep them. And when she moved into the new house, she hired an electrician to come and install and hook up this chime in her new home. When the fella came out to do that, he made some pretty bad choices as to not necessarily how to hook it up, but how to go about putting it together when he was hooking it up. And when he did that, he damaged the chime. The idea behind this is what probably occurred was going up here on the chime base, there would normally be 5 screws. You have external front connection, then you have front, common, transformer, side, and rear. These screws are where the wires would be connected from the different, either the transformer or the different push buttons, so the chime activates the way it's supposed to. One of the things that happens on this model, if the screws are loosened and tightened many times, or if they have too many wires on them and someone over tightens them, is the holes for the screws can become stripped out because basically they're sort of self-tapping screws and they thread into the fiberglass circuit board, the red part, and then they tighten down and push the wires against the traces, and that's what makes the connections. This chime is from 1985. I'm guessing that when the electrician went to hook this up, he found that the screws in these locations, not so much external front, but front, common, and transformer, wouldn't tighten down correctly. And that's when I think he went to his truck or reached in his tool bag and pulled out one of these. And this screw is about twice the size of the original screw that was in the chime base. When he did that and he ran these screws in through the original holes, he ripped apart the circuit trace. These are the circuit traces on the red circuit board, and although most people would not think of this as a circuit board, it actually is. It isn't really any different than the board that's in your mobile phone or in your computer or any other electronic device. They're just larger traces on a fairly simplified sort of design, but they are circuit traces nevertheless. They're designed to carry electricity and make connections, and as you can see here, this is the common terminal, and when he put the screw in, he ripped the traces, it pulled them up off the board. This is how it came in here, and the traces are broken and basically the connection is lost. Here for the front connection, this portion here is missing. It's actually torn right here, and actually this one got ripped up so much there was actually another screw in this hole, which is not a hole that's normally used, and that trace was torn up also. And the one for the transformer, it's a little wider. The problem with putting in a really ginormous screw like this is that around the edges of the opening here and here and here and here and here and here, the trace is pretty narrow if you compare it to what it's like on the ends. This one's a little short there, but here and here and here. So if you ram in a screw that's the wrong size, like this one, then you're going to rip up the trace. And of course this annoys the heck out of me, and the other reason that I find this very annoying today is that this is actually the second chime I've had sent in like this within the last couple of weeks. The other one came from a fella who is supposed to be a handyman in Arizona. He had sent me the chime base and cleaned and serviced it, and it all worked correctly when I sent it back to him. And then he said he went to put it in and it only worked once and it didn't work right, and the lady was upset and all these other kind of things, and he sent it back to me, and I found basically the same thing. I found these big giant screws that he had jammed into the holes, and when I called to talk to him about it, I asked him what was up with that? Why did you do that? And he said, well, the other screws I couldn't get them to tighten down properly, and those are the only screws I had. And I said, well, the screws you had ruined the lady's chime, and I was able to repair it, but it's just unnecessary. You know, these are hard to come by devices nowadays, and if you're going to work on it and clean it and service it, you have to be careful with it. This proves one of the things I've always believed, which is just because you're paying someone to do something doesn't necessarily mean they're going to do a better job than you could do. What we're going to try to do is we're going to try to repair this, and we're going to try to repair it in a way that makes it functional and also will make it long lasting. Now, we're not going to go through and try to repair all of the circuit traces and bond new foil paths to the board. That's all way too complex for it's a doorbell. But it has to be done properly. So let me show you how I think I'm going to do it. So what I'm going to try to do is I'm going to use this. I have a threaded screw, a machine screw, a nut, and I have a washer with a serrated opening inside the washer. And what I'm going to do is I'm going to repair the foil traces where they're broken the best that I can. I'm going to solder the broken parts back together, and then I'm going to place the washer on the traces, and I'm going to solder it in place to the trace, and that will help reinforce it. It'll help reinforce the trace. And then the screw can go through the washer out the back side of the board, and then I'm going to put a nut on the back to hold it all together. When I do this, I'm going to attach wires underneath the heads of the screw, and I may put another washer under the head of the screw also, just to make it larger, so it'll be the head of the screw, a washer, the wire, and then it sits against this washer, which is soldered to the board, to give it more bite so the wire doesn't slip out. And then when I send it back, I'll label the wires and explain to the customer, don't loosen the screws, don't take the wires off, just hook up to the wires that are already there with your wires and you'll be fine. These screws fit through the holes that were enlarged when the electrician put the giant screws in, so that won't be a problem. I'll have to cut these off at the end because these are a little long, but that's easy enough to do also, and I think this will probably be a good repair. One of the other things I'm going to do, which is sort of a cautionary thing for everyone, is part of the chime base is this metal tab right here. The purpose of this tab is it's connected to the front trace on the circuit board here with this screw. It goes back underneath the motor and it's resting against another contact. As the armature of the motor begins to turn when someone pushes the button, it pushes it down off the contact and allows the chime to run through its cycle, and then there's an arm on the armature and it pushes it and makes the chime stop at the end of the cycle. When the customer was cleaning the chime, this is a fairly thin piece of metal, and right here in the fold it started to crack. It's cracked about halfway through the fold right now. And if this breaks off and gets lost, which is really bad because these are not hard to replace and they're not available anymore, then the chime would run endlessly. It'll never stop. So I'm going to solder the crack also to reinforce it. So that's a fairly simple thing. We do that a lot on these bases. So I'm going to go ahead and see if I can get this straightened out and get some washers soldered in place, and let's see if we can get this chime working. Okay, so a little time has passed and you can see I have the 3 serrated washers soldered in place on the front common and transformer paths or circuit traces. They look a little lumpy, but this is not an easy thing to solder and make it sturdy, but they are soldered in place. They're not going to fall off. I also soldered the seam on the little tab right here, and that's lined up so that won't break. So now I'm going to go ahead and put the screws and the nuts in place, and then we'll hook it up and see if my idea works. Okay, so I've got the 3 slotted screws in place. I did put another serrated washer under the head of the screw, so we have a screw, a washer, the soldered washer, so the wire will go between the two washers, which I think will give it a good bite so the wires won't come out. And then on the back side, I put another serrated washer, a small split washer, and then we have the nut. And after I attach the wires under the washers on the front, and I tighten it all down, then I'll snip off the screws because they're too long and they won't allow the base to mount against the wall properly. But that's an easy thing to do. So now I'm going to go ahead and hook up the wires, cut the screws, put everything back together, and then we'll test it and see if I was clever enough. Okay, so I've got all of the screws and washers and nuts in place. I've attached wires under each and every screw. Even these two bottom ones, which are original screws for the rear and side, I put wires underneath them. I don't want anybody undoing the screws and messing around with all of that. So the color coding I chose is actual traditional NuTone color coding. So for common and transformer, these are the wires that come from the transformers directly. I use black wires. I have a red wire for the front terminal, an orange-white for the side, and orange for the rear. I've got the motor back in place. Everything is set to go. So let's go ahead and power it up. And our lights come on as they're supposed to. And I've got the selector switch in the 8-note position. So we'll go ahead and I'm not gonna make up a button per se. All you really have to do to test these is take the wire from the front terminal, which is red, and touch it onto the common terminal. And that triggers the chime. And it's running through its sequence. And if you watch down here, you can see the plungers pop out. We'll do that again. And that's fine, so it runs through that sequence fine. We'll go ahead and ring it on the 4-note ring, which is just the first 4 plungers. And that's fine also, so we'll wait till it stops. And then the rear door terminal is just 1 plunger, this one here, and then the side door is a different single plunger. It's this one here, and that one works, so we're in good shape. Let's go ahead and take one close-up look at the plungers. So go ahead and watch the plungers down here. We'll do the 8-note ring this time. And they work just fine. So I would say this is a successful repair. So the moral of the story is this was a successful repair. I feel that I was clever enough to figure out how to fix it for the customer. And the moral of the story is don't assume that because you're hiring someone and paying them to come out and do something that they're going to do a better job than you might be able to do yourself. This isn't the kind of thing that everyone can do, but with a little bit of instruction and a little bit of thought, most people can do something like install a chime base. You know, NuTone products were always known for having good instructions, and they were sold at places where ordinary consumers and homeowners could go and buy them, take them home and install them yourselves. It is something you can do. That's all for today. Harvey says that it was a successful repair, and Harvey's happy. Harvey is our shop mascot now. He came to us right after the holidays. He's our YouTube and social media expert. And Harvey says, subscribe now. He said these ads are ad-free. See, he's so excited he dropped his sign. He's protesting the lack of subscribers. He says this video and our YouTube channel are ad-free. We're not boring you with ads about building a website or something else. All we're really looking for is possibly a thumbs up for our video if you found it interesting and helpful. And if you would subscribe to our channel, more people will watch it. We can help them with their door chimes too. And that keeps Harvey in hedgehog chow. And it's not cheap, let me tell you. And he gets really cheesed off if he doesn't get fed regularly. So Harvey says subscribe now. That's all for today. See you on the next video.